The advantages and disadvantages of von Neumann architecture and Harvard architecture. Von Neumann architecture. The advantages are the following: cheaper to use than Harvard, program locality. Third is that separate data buses are not required. Next, control units gets data instruction in the same way from one memory. It simplifies design and development of the control units. The next one, less physical space is required than Harvard. Next, handling just one memory block is simpler and easier to achieve. And the next one, data from memory and from devices are accessed in the same way. And the last, memory organization is in the hand of programmers. The disadvantages of von Neumann architecture are the following: shared memory, which means a defective program can overwrite another in memory, causing it to crash. Second one, more relics, which means some defective program fail to release memory when they are finished with it, which could cause the computer to crash due to insufficient memory. And the third one, data bus speed. The CPU is much faster than the data bus, meaning is often site idle von Neumann bottleneck. And the next one, fetch rate. Data and instructions share the same data bus, even though the rate at which it needs to be fetched is often very different. And the next one, executes instructions serially. And the next, limited by the times it takes to process each instruction. Some registers are still not being used during the fetch, decode, execute, rest cycle. Serial instruction processing does not allow parallel execution of program. Only one information can be accessed at a time. And the last one, instructions stored in the same memory as the data can be accidentally rewritten by an error in a program. Harvard architecture. The advantages are the following: efficient pipelining, operand fetch, and instruction fetch can be overlapped. The second one, separate buses for data and instructions. The last one, tailored towards an FPGA implement, which means Field Programmable Gate Array. The disadvantages of hardware architecture are not widely used, more difficult to implement, more pins. This is the example of graphic of von Neumann architecture and Harvard architecture. In the von Neumann architecture model, we have input in the left side, and the middle of is control unit, ALU, CPU, memory units. And the right side we have output, and this is example of von Neumann model. And for the Harvard model, we have, for the right side we have instruction memory, and for the middle we have ALU, control unit, and IO. And for the right side we have data memory. So this is an example of von Neumann architecture and Harvard architecture. So that's all. Thank you.